Good morning, everyone. Remember, you have assignment one, due date, Monday. Hopefully you have the opportunity to review use case diagrams and class diagrams. So we have been working with this idea of the Pac-Man. The last time you helped me to create this diagram. We talk about the requirements, we review the diagrams with the use cases. We talk about how to implement this. And you help me to define some classes, the ones in the picture, and you help me to connect those classes. And we review in detail in the previous lecture the meaning of the connections. So at this point, you are experts with what is the meaning of each of those elements. And well, we have this partial solution for the game that we're trying to implement. From the use cases to this diagram. That is something that we have done before. Now, I want to complete the diagram. There are things missing there. And I want to implement this because at the end, the product is the software. What I need to do to put this in source code and have my game running. Let's review that today. Implementation. How to do object-oriented programming from a diagram. These are the classes that you give me. These are the classes that we have in this picture. We did this drawing. So the classes, help me. Connection between game and ghost. Three options, be, has, or use. Has, okay. When you define has, remember, game, has. Then you have two options with has, aggregation, composition. We already discussed this, aggregation or composition. In this case, composition. Composition, probably the black diamond. Why? Because it is mandatory to have the element in the game. If not, we do not have the game. Remember, the diamond represents that you have something. Having something is a global variable. The only difference is if it's mandatory for that variable to be initialized, different from null or not. So in this case, when we put the diamond in black, is I need a variable or for, if we want to use the number, those objects that are going to be in the class game should have a value, should have been initialized. It's mandatory to put new to something when the program starts. And I am thinking about the constructor of the game. If I put the diamond use white, that means that I have the variables, but whether or not they have a value, maybe they are null during the full program or during a period of time, and that is fine. In this case, I am using this black, asking for the developer that code this to put the new for ghost in the constructor or at the top of the class. That was a discussion that we had in the previous lecture, like, well, whether or not we want to allow the game with or without ghost. Again, the decision, whatever decision you take is fine. The only thing is black or white, and that should match with the source code that you create. The previous lecture we talked like, well, no, it will not make sense having the game without looking at the ghost moving or the yellow circle with the Pac-Man. So let's make this mandatory. And if we decide to make this mandatory, the only thing that we do is, okay, let's put black the diamond. So the same decision we take between the ghost and the Pac-Man, and the same decision we take with the power dots. And well, we can continue, but at least we think about, okay, the power dots, maybe you want to have four also, the four ghost and the Pac-Man. And if you want, well, the maze also, one. So we start with this idea about I want to have all these things. For the ghosts, the idea is that they are always there. I mean, you never miss a ghost. You eat a ghost and immediately it's available in a different position. Really, for this case, I think we talk about it is the ghost is always alive. When you eat, really in the game, it's only change the position, but never disappear, never is destroy the object. Now we're talking about mandatory, mandatory, mandatory. Oh, well, this is not mandatory. And again, two things here. One, the diagram helps us to share ideas. The diagram helps us to be clear about what is going to happen with this in the program. But number two, this diagram is the blueprint for the developer. What I am going to ask the developer to do. In this case, I need to start thinking about what is going to happen with the game when we implement the game. And here, the first issue that we're going to have. The game needs access to the maze. The game needs access to the ghost. The game needs access to the Pac-Man. That makes sense. I have a question for you. The game need access to the power dots? Or maybe the power dots is an item connected with the maze, not with the game. My question is, we want to put the aggregation, the variable power dot in the class game, or we want to put the variable power dot in the class maze? And why? The only one that we really need connected with game, the only one that we cannot change the decision, the only decision that is mandatory to be connected game and Pac-Man, that is mandatory. That is the only one that we need to have in that way, that is the answer. But I want you to think about the ghost and the power dot. I start with the power dot because it's the one not moving. But as you mentioned, it's the same decision that we can have for both. And we do not need to implement the same code for both or the same decision for both. We can have one connected with game and the other connected with maze. My point is, this one or this one can be connected with this class instead of with this class. You have the option to connect them with any of them. It's your decision, it's your program. In both, they are going to make sense. If you connect them with the game have ghost and have power dots. Or if you connect it with the maze, well, the maze is the one that is going to have them, but the maze is in the game. So at the end, you have the three of them. I want to talk about why I am mandatory connecting the Pac-Man with game, and the Pac-Man is the one that I am not allowing to be connected with maze, like with the other elements. What makes the Pac-Man different from the others? Exactly. You want to control the Pac-Man with the arrows, right? With the keyboard. And in that point, you're going to be using a listener. Now, something that we agreed before is let's connect the listener with game. I need to be sure that the one that have this connection is also connected there. Why? Because whatever the user is going to do with the keys is going to be reported to the listener. The listener is going to report that to the class, which the one is connected, assuming that you implement the method there, that usually happen. And inside of that method, you want to do something. And if I am talking about a method here, well, somehow this method need to do something, and that something could be called another method or modify a value, whatever. But the only thing that can do is call a method from a class or modify a value in a class to which is connected. Now, you can have an indirect connection. You can have the connection to the maze And that means that in this method, you are going to send some kind of value or call some kind of method in maze, but the only thing that maze is going to do is to call another method in the pacman or pass the value to the pacman. So you have one action that is going to go to one point, and in that point, the only thing that is going to happen is send to another point. And this one notification imply two jumps is something that you want to avoid. So if you know that the key listener, the user, is going to do something that is going to be notified to game, and that is going to affect somehow the yellow circle, well, it's a very good idea to have this direct connection there. The diagram should show me exactly what is happening in the code, and somehow you can figure out how many lines. So moving forward, can you agree with this? Is key listener to the game to the pacman. Fine. Now, the other thing that we did, if you remember, was this connection between game and frame. The connection for that one was inheritance. The game is the one that is going to create the window, right? So the window, the listener, the pacman, mandatory. The game is the one that is going to have the maze. In fact, we want to put the maze in the full screen of the game, right? Tell me, this is the part in which we need to mix our knowledge of programming with our work as a designers. What element in Java Swing you can put inside of a frame in order to cover the full empty space? What things you put inside of a frame? Okay, option number one, canvas. I like that one. There is a class canvas, do you remember? If you want to draw things in Java, you have the option to use canvas. Now, two things. Usually the class canvas or using canvas is something connected with AWT. It's easy to do. There is a class. There is kind of the older way to do it. What is the new way? The new way is using a panel. What is a panel in programming? Any space that you can put inside of a frame. In the swing model, exactly. In the swing model, what you have is these frames, is the window, the frame. Inside of the frame, you can put panels, as many panels as you want. And inside of the panels, you can put more elements, or you can use the panel as a canvas. Okay, you have the game. Your game receives events from the keyboard. Your frame is connected with the pacman, so you are going to be able to communicate with the pacman. Your game has a maze. The maze is going to be a panel, so in some point you are going to be able to add the panel to the frame. In this case, add the maze to the game. And we're connecting programming graphical user interfaces with Java with our goal here. Now, for the ghost and the power dot, whatever solution you choose, connecting them with the game is fine. Why? The game can have these two as a variable, and in some point, inside of the source code of the game, when we create the maze, we can send them as parameters. If we create the both of them in game, then we send them as parameters. So the maze is going to have access to them, pass as a parameter. Or we can put them, both of them, connected to maze, and maze have direct access to them. Both options are fine. Why? Because this one do not need any data from other class that is connected with game. There is no reason for them to be on game except one. There is one rule in programming. When you have a program like this, the recommendation is all your news, all this creation of objects is recommended to happen in only one place, in only one point. It's going to become the idea of factories that we're going to review later. But following this idea that the recommendation is one and only one class or only one module component is the one responsible for creating new objects, that is the only reason because I could connect Pac-Man, Ghost, and the power dot to game, because then game is the one that have all the news. But again, that is a concept that we need to review, factories. Right now, if we ignore that recommendation, I can move Ghost and power dot to the maze. The news for them are going to happen in maze in the same way that the news for the Pac-Man is happening in game. Okay, one more thing. Do you remember that we want to move the ghosts by themselves at the same time that I am moving the Pac-Man with the arrows? The question is, what can we do in order to solve that problem? What do we need in order to have something like the ghosts moving without the user doing anything? Moreover, while the user is pushing the keys to move the Pac-Man. What is the solution in programming? What is the solution that we know that maybe we can showcase in this diagram? Don't worry, I'm going to fix the arrows. Right now I'm just connecting things. There are two ideas in Java, right? Idea number one, threads. In one thread, the program is waiting for me to press keys, but in another thread, the program is working in something else alone. The program is moving the ghost. I need to define under which pattern, but that is happening. They are moving. There are two ways in Java to do that. There are two ways in Java to have the program doing different things at the same time. Option number one, threads. In particular, you have a class thread, or you have an interface runnable. I do not know how many experience do you have with that, but that is option one. Option two, and I am going to use in this example the option two, the easy one. In the option two, there is a class timer. You create an object timer. You define a particular number of milliseconds, and every time that that milliseconds happen, the program do something. A timer, literally. When you reach the timer, trigger a method, call a method. I think we can use that for the Pac-Man. We can define a time, 100 milliseconds, 10 milliseconds, depending on the speed that you want. And we can have this timer calling a method. And probably that call to the method could be moving the ghost. So we're going to have a timer moving the ghost, and we're going to have the keyboard moving the Pac-Man. That makes sense. Sounds like something that we can use. I am going to complete my diagram now. Game. Game is going to be doing implementation of key listeners. Hopefully it's clear why I am using that arrow. Game. Game is going to be inheriting from frame, and hopefully it's clear the difference between one and the other. Game. Game is going to work with timers. Working with timers, two things. Number one, I am going to use a timer. And every single time that the timer is activated, I need to call a method. And in order to use something that is familiar to you, the method that I am going to call is action perform. I am going to call with the timer the same method that usually you call when an event happens in a graphical user interface. If I want to call the action perform method, if I want the timer to create this event that automatically trigger an action perform method, then I need to use the action listener for the timer. And that is the reason because I add another blue box. The connection between game and action listener, something like that. At this point, game implements action listener and key listener. Game uses a timer inherit from JFrame. And hopefully you are figuring out the source code for game because we need to review it. You need to help me to create it. Now, next, mandatory. The game is going to have a maze. I think in this decision we agreed it should be composition because there is no game without the maze. At least we can define that, right? The maze is not going to disappear. The maze should be there always, etc. So let's use a black diamond game with the maze. The maze, we talk about it, is something that is going to appear on the screen, full screen. The maze is the one that is going to fill the frame. We're going to use a panel, and therefore the maze is going to be a panel. Panel is a class, just like frame. So here we need to apply inheritance. We have the game connected with maze. The maze is a panel, and so far everything is moving. Now, here, something that we agree also is the Pacman. The Pacman should be connected with game because every single time that we do something with the key listener, we want to connect with the Pacman. Again, we can connect the Pacman with maze and then the game notify maze and maze notify Pacman. But if we try to avoid that intermediate steps, we can connect directly. Moreover, according with our conversation before, well, probably if what we are doing is to implement the Pacman video game, we can make kind of mandatory to have a Pacman there. But again, it could be something that you can define. If you are okay with only the maze and in some point there is no Pacman there, it can be used as white diamond. In this case, my diagram is telling it is mandatory. I want the Pacman there. So the ghost and the power dot is whatever you want to do. Whatever you want to do, I mean, you can connect with game. You can make it mandatory or optional. There is not going to be difference except the line with the new. If you connect with game, then you can pass as a parameter to the maze, is option 1. Option 2, you can connect directly with the maze. I want to share with you an example of both cases. I am going to do the ghost connected with game, so you notice the solution. I am going to do the power dot connected with maze, so you notice the other solution. You are going to notice they are almost the same. Yeah, the ghost is going to be moving, change the position, and the power dot is going to be static, but that is because a couple of lines that we're going to have there. So one connected here, the other connected here. Now, in this point, I need to introduce another challenge. Do you think that there is something in common between the ghost, the Pacman, and the power dot? All of them are elements, graphical elements, that they are going to be on the screen, right? So they need to be drawn. In particular, somehow, because all of them are going to be drawn, well, probably All of them at least need a method draw. All of them share this thing in common. When you have something like this, in object-oriented programming, is this request for you to use inheritance. You have these three classes that should be a family. They are, yeah, one is a circle in yellow. The others are these guys with the big eyes. And the other is, well, use a dot in white. But they are three graphical elements that are going to be somehow inside of this maze. So one recommendation for you, and I am going to apply that here, is if we want to put them in the same family, well, we can define a father for them, a common class. I can define a parent, and in this case, I put this rectangle in green just to tell you it's another class. It's not a class that is solving any problem. It's just this idea that maybe it's going to be useful to have a parent for them, and I am going to show you why it's important, the parent. Anyway, now I have two solutions, two ideas. Number one, I can create a parent that put them together, and that parent can be a class. Another option is I can create a parent, quotation mark, and that parent can be an interface. I have both options. I am sure that you are familiar with using classes for parents. I am not sure how familiar you are using interfaces to connect things. I am going to use an interface, use for fun. Why? I just want to show you that you can use this relationship between two things that you create. It's not only for things that are from the libraries. Advantage or disadvantage. If I use as a parent an interface, the only thing that I can have in common is methods, empty methods. For this program, it's fine. The only thing that I want is to be sure that because all of them are a family and the parent, the interface, is defining a draw method, well, all the childs should have a draw method. Here, I am going to define how to draw the ghost, how to draw the Pac-Man, and how to draw the Powerball. Yeah, but the maze, what is going to happen with the maze is the maze is going to be drawn. I can have here a draw, but there is a problem with the maze. The maze is going to be a panel, and the method for drawing in a panel have a specific name, a predefined name. Just like the main is the main method in any program. If I want to use a panel and I want to draw something in the panel, there is a paint component method that I need to override. So the painting of the maze is going to be in this paint component method because that is the method that I am inheriting from the JPanel. And because of that, this maze do not belong to the family in which I am including Ghost, Pac-Man, and PowerDot. And in somehow makes sense. Think about the maze is kind of a house, and the Pac-Man, the Ghost, and the PowerDot, these elements are inside of the home. So the home is in a different family or in a different tree. And these guys, because they are going to be inside, well, they can be family. Something that we need to think about here is, well, what happened in the computer graphics, you are really drawing things, all things, every time that you make a change. So it's going to be drawn several times, don't worry. I'm going to show you. But the main thing is, the maze is going to be drawn in the paint component method because that is the one that you take for JPanel, one thing. And when you are working with graphics, usually you have one method that do the drawing, one method that draw everything that you want to put on the screen. Why one? Oh, because you do not want to have conflicts. But I want to have the Pac-Man and the four walls and the, yeah, you can have whatever you want. You can have a full 3D video game. But inside of the computer, there is one element, one method in which you do the drawing. Which is going to be that method? This method. In terms of painting, that is the method that is going to do the painting. What is going to happen with the ghost, the Pac-Man, and the power dot? The same that happened in the main in a program. The main is the only one that run when you run your program, but the main can call other methods. Well, in a program, the only one that draws something is the paint component. What can I do? Paint component can call the methods in the other objects for drawing. So paint component is the one drawing, but it can ask for help to the draw method in Pac-Man or the draw method in the ghost or the draw method in the power dot. But those methods need to be called here, because here is where the drawing happens. Now, what can I do in Maze if I want to call methods from Ghost, Pac-Man, and Power Dot? You agree with me that I cannot call those methods unless I have access to the objects. I need association, that is correct. Now, option number one, I can associate the maze with the ghost because I am going to call a method there. I can associate the maze with the Pac-Man because I am going to call a method there. I can associate the maze with the power dot because I am going to call a method there. And notice the idea here is the maze associated with the power dot. The maze is going to use the power dot because the maze is going to ask the power dot, you power dot, draw yourself. You are going to be the one drawing whatever shape you want to have on the screen. That is the object-oriented thinking. Now, I can connect use to all of them, or there is any way that I draw only one line and that one line represents that I am going to use all of them. Can I do that? There is a reason because I put a parent here. If I put a parent and if I connect maze with the parent, do we agree that connecting or using the parent mean that I am using or I can use any of the childs? That is object-oriented. You use whatever is the parent, and that use relationship apply to any of the childs. So this line using imply that I can use a ghost, or I can use a Pac-Man, or I can use a power dot. Moreover, not only use, you want to have. I am just playing with the diagram, but my idea is the same. Is I can say that I have mandatory the parent, and basically what I am telling is I have any of this. Because remember, this green is an interface. The interface is not an entity. I cannot create entities from the interface. So drawable do not exist. If I say that I have one of these, or two, or three, what I am asking is to have the others. This is my class diagram, the full class diagram. You can transform this to source code. Yes. Interface. Could you agree that that is the interface that I draw? One interface, a method, is receiving one parameter. We need to see what we're going to do with that parameter, but is the parameter that we're going to use to draw things. Very easy, right? The parent. let's see, the power dot is a class. That is in the diagram, right? Mm. Two variables, hopefully it's very, very clear. One constructor, someone is going to create the power dot. Who is going to create the power dots in my diagram? Game. Okay, in game, or maybe in maze, you are going to do news for the power dots. And when you do news for the power dots, you can send the X and Y position for the power dot, and you're going to store that in the variable, just like any other class. And then you have this draw method. You are inheriting from the interface, so you need to provide the draw method. The draw method have this parameter. That is an object in Java. Set color and fill are method there. My power dot is basically a rectangle in white. This is the size and the position, whatever I have in the variables. Hopefully this is kind of trivial. Okay, the Pacman. Also a common parent. The same variables. The draw. The same parameter with the same method for colors. Okay, Pacman is going to be also a rectangle. You can change that for fill oval. Now it's a circle, but rectangle. In the position, whatever, I don't care. It's according with the variables that I have, and the same 2020. What I am doing here, 11 to 14, checking that the Pacman do not go outside of the boundaries, right? It's not a good idea, but just for you, my screen is going to be size 400. So the only thing that I am checking is, well, never the variables are going to be lower than 0. 0 is the minimum, no greater than 400, because then the Pacman go outside. And it's going to be the same for X and Y. Just quick review about the boundaries. Okay. I put these methods in the Pacman that hopefully you can remember. Up, down, left, right. The Pacman is not really moving. The only thing that I do is change the value for the variables. Up, down, left, right. Increase or decrease the variables. And that is Pacman, okay? The ghost, the same parent, the same variables. Oh, my method draw. This is a little bit more complicated. It's not yet the one for Pacman, but in this space is the space in which I can be creative and draw all the engine for the ghosts. Notice that I am implementing only one ghost, but you tell me that there are 4 different ghosts with 4 different patterns of movement. So these ghosts can be really the parent for the blinky, pinky, etc. And each of them are going to have a different draw method, which means each of them is going to have a different way of be draw, a different way to move. In this case, do we understand what is inside? The only important line, the same parameter with the graphics, and the only line that is important is I am drawing my ghost again as a rectangle, and this is a red rectangle. What is your algorithm for moving? Random. Do we understand the line 9 to 18? What is happening 9 to 18? Math.random, random numbers, right? Random movements. Random up, random down, random left or right, almost 25% of chance. If you change this, if you apply inheritance, you can implement the movements of the different goals. This is just trivial example. Anyway, the power dot, the Pac-Man, the ghost, the common parent, these are the trivial ones. I need to review the other classes. I am going to do that in the next lecture, but this is my result. You have the slides. I am going to publish this. If you have the opportunity, please play with the source code. The important thing for me is that you connect the diagram with the source code, that you notice that everything in the diagram is in the source code, or what happened if we change the source code, what we need to change into the diagram. But we continue next week. Okay, any question? Okay, see you next week, guys. Thank you.